Okay, you know what time it is. EOC countdown, question number 26. Okay, so as you can see, all right, we have a what? A graph, and we have a line. Okay, so you should automatically be saying to yourself, automatically, knee-jerk reaction, automatically you should be saying to yourself, y equals mx plus b, because that's the slope-intercept form of the equation of the line. However, okay, it says the graph of f of x equals x. Well, guys, okay, you know that f of x, g of x, anything of x means the same thing as what? Y, okay? So y equals x, and we know, and I'm going to write it down here, so f of x equals x, and we know that f of x means the same thing as y, and even though it's not there, you know there's a what there? 1. And even though there's no y-intercept here, what does that mean, you guys? That means that this line, that where the y-intercept, where this line crosses over the y-axis is at what? 0, 0, which is what you see right here, okay? So, having that been said, all right, here's the equation f of x equals x, all right? And we know that this is a positive slope as we read graphs from left to right. We know that this is a positive slope, and again, it crosses over the y-axis. The y-intercept is at 0, 0, and it has a positive 1 for its slope. So the question says, describe how, let me just erase this. Okay, describe how the graph of each of the following functions, you have a function A, B, C, and D. So we have to describe how each of the following functions compares to this function here. Okay, and remember what I told you. They're going to call this line, a function, a graph. Okay, so all three mean the same thing, so get on board and get used to it, okay? They're calling this line the graph of the function, all right? So how does g of x equals x plus 3 compared to this line? So once again, anything of x means the same thing as y, so don't get intimidated by that, no big deal. But here we have x plus 3. Well, how does this compare to this? Well, I'm noticing, okay, that they both have the same slope, right? And what do we know about lines that have the same slope? They are parallel to each other, right? So here we go to a positive 3 for the y-intercept, which would be right here. And it would go up 1 over 1, up 1 over 1. And if you just connect the dots, that actually is the case. So I'm writing this as you're writing it in your bell work. You can do all 4 of these on the same graph, okay? You can graph all 4 of these on the same graph. I don't have 3 more different marker colors, but we're going with it, okay? Now look at B, h of x, you know, y equals x minus 5. Well, here we go again. You know, f of x equals x. They have the same slope again. That even though it's not there, there's a 1 there. So it's a positive 1 over 1. So the slope is a positive 1. Well, obviously the slope is a positive 1 here for B as well. So this function is parallel to our original as well. So, but where does the line cross over the y-axis? At a negative 5. So I'm going to put the dot on the negative 5 there. Up 1 over 1, up 1 over 1. And we'll just connect the dots and draw our second line. You don't necessarily have to do this, but I'm doing this just to give you the visual to show you that, you know, when they have the same slope, right, we're looking at parallel lines. And so that's they're both parallel to the original parent function there. Okay, so now let's look at C. We have a negative 2x. Well, obviously that's a different slope from the original. So and there's no y-intercept. So obviously it's starting out at 0, 0. So the way that C compares to the original is that this function also goes through the origin, and the slope is a negative 2. So down 2 over 1, down 2 over 1, down 2 over 1. And we'll just create that. Okay, and so again, it says describe how the graph of each of the following compares to the original. Well, here's our original and here's C. So C is obviously a negative slope, whereas the original was a positive slope. Okay, and now here we have D, our last function to graph. So we have a positive 8, which is going to be right here. So it crosses over the y. So that's one difference. It's got a y-intercept of a positive 8, and the slope is a positive 3. So from there up to 3 over 1, up to 3 over 1, and connect those dots. And here we go. So as you can see, I'm going to put the ruler right here. The positive slope of this graph is much rises much more quickly, okay, whereas the original slope is more gradual. Okay, so that's basically comparing each of these functions to the original. Okay, so make sure you represent that in your bell work.
So what's the answer?
Okay, you know what?